Welcome to Lesson 2 of Linux Mastery, the one that finally puts permissions to bed. Permission denied is the most Googled Linux error, and most engineers fix it by throwing random chmod commands at the wall until something sticks. We're done with that. By the end of this lesson, you'll reason from a single model. 9 bits plus 3 special bits covering chmod, chown, and sudo. A mental model that fits in 30 seconds and lasts 30 years. So why do permissions even exist? One reason, Linux is multi-user, and your stuff shouldn't be readable by everyone with a shell. Look at the 4 classic problems on screen. They map cleanly onto the model. User reading another user's secrets? That's the owner bits. Web server locked out of app files? Group bits. Random files and TMP exposed to the world? Tighten the other bits. And junior engineer who needs to restart Nginx without root keys to the kingdom? Targeted pseudo-wars rules. 4 problems, 4 directives. All from the same model. After this slide, every permission denied you hit has a category. Here's the model itself. 10 characters, 1 type bit, then 3 groups of 3. The first character tells you what it is, dash for a regular file, D for a directory. After that, it's just user, group, other, each getting read, write, execute in that fixed order. And the numbers aren't magic. Read is 4, write is 2, execute is 1. Add them per class and rwxr-xr-x becomes 755. Once you see it this way, you read permissions like English, not hieroglyphics. Now that you can read permissions, let's set them. Chmod speaks 2 dialects, numeric, like chmod 755, which slams down an absolute mode in one shot, perfect for fresh files where you know exactly what you want, and symbolic, like chmod umask or chmod or, which makes a surgical change without touching the other bits. The rule is simple. Numeric for fresh sets, symbolic for deltas. And watch that capital X on recursive calls. It adds execute only to directories, which is almost always what you actually meant. Chmod controls what each class can do, but chown decides who those classes actually are. The syntax is compact. Chown Alice sets the owner, chown Alice. Web app sets owner and group together, and a leading colon changes just the group. Groups are where it gets interesting. A user has 1 primary group plus any number of supplementary ones, and that membership is what unlocks group permission files. Here's the trap that bites everyone. When you run usermod ag to add someone to a group, it doesn't take effect until they log out and back in. Group membership loads at login, not live. And always remember the A, forget it, and you'll wipe every other group they belong to. Now scale that thinking up to sudo. Sudo isn't a write, it's a delegation defined in POSIX ACLs pseudo-wars. The default Ubuntu line gives anyone in the sudo group full root, which is fine on your laptop but reckless on a shared server. The better pattern is granular. Let Alice restart Nginx and nothing else, no password prompt, scope through a command alias, and always edit with vsudo. It validates syntax before saving because a typo in pseudo-wars locks everyone out, including you. Beyond those 9 bits, there are 3 more that every senior eventually learns to recognize. Setuid makes an executable run as its owner, not the caller. That's exactly how passive lets you edit, etc. shadow without being root. Setgid on a directory forces new files to inherit the directory's group, which is gold for shared workspaces. And the sticky bit, the one on TAN-EMP, lets everyone write, but stops them from deleting each other's files. 3 bits, 3 very specific jobs. Now zoom out, because this model isn't just a Linux thing. 3 principles travel with you everywhere. 1, default deny. Linux ships 644 and 755, which already let the world read. The senior habit is to tighten first and open deliberately. 2, least privilege scales. The same logic behind pseudo-wars lives inside AWS IAM, Kubernetes RBAC, and GitHub permissions. And 3, always read the bits before you change them. chmod R777 on / is how careers get interesting at 3 in the morning. So here's your cheat sheet. 12 modes that cover almost every real situation you'll meet. 755 and 644 are your daily defaults. 600 and 700 lock things down to just you. The 640, 750, 664, 775 family is how teams share work safely. And the special bits live at the bottom. 1777 is RTMP. 2775 gives you setgid group inheritance. 4755 is your setuid binary. And 01 or 0 is the nuclear option. Print this. Pin it. 2 weeks from now, you won't need it anymore. Now we turn theory into reflex. 3 drills, 30 to 45 minutes total, each one building on the last. First, you'll read 10 real permission strings out of T, etc. until rwx stops looking like alphabet soup. Then you'll solve the classic shared directory problem. Group, chgrp, chmod 70, and the inheritance gotcha that bites everyone. Finally, you'll grant one user sudo access to exactly one command and verify everything else still fails. Do all 3, and permission denied becomes a 30-second fix for the rest of your career. Before we close out, let's inoculate you against the 5 mistakes that cause most permission disasters in the wild. Never chmod R711 anything. It doesn't fix problems, it nukes them. Always use user mod with -a, or you'll wipe a user out of every group they had. Edit sudoers only through vsudo. SSH private keys must be 600, the .sh directory 700. And when you recurse with chmod, use capital X so only directories get the execute bit, not your JPEGs and style sheets. Memorize the fix column. These are the patterns that separate guessing from reasoning. And that's permissions decoded. You now own the 9-bit model, you can chmod fluently, you understand chown and groups, and you can write pseudo-where's rules with surgical precision. Next up, processes and signals, PS, kill, jobs, and knowing exactly when to send sigterm versus sigkill. Foundation stage 3 of 4, I'll see you in lesson 03.